Hello, my name is Tatiana and I'm a data analyst in IT company. Today, I'll explain you what is A/B testing and what should be calculated in the end of the experiment. This concept is crucial if you are willing to make data-driven decisions related to product, business, science, or whatever. This topic is also popular among employers looking for data analysts and data scientists. I've created the easiest and the simplest way to do these calculations right in Google Docs. And I would like to share it with you. Good news, you don't need to do any coding to use this instrument. A/B testing is aimed at estimating difference between two options. For example, you work in Netflix and you would like to increase conversion from session to video watching by introducing changes in recommendation system. Then all users can be divided into two groups, test and control. Users in test group will start to get recommendations by new system, while users in control group will continue to get recommendations by current system. It is very important to calculate needed number of observations before you run the experiment. I won't focus on this requirement now and will explain it in next videos. During the experiment, you collect data describes behavior of test and control users. After you obtain needed number of observations, you should calculate the difference between two options and its statistical significance. In the example of conversion from session to video watching, user has only two possible options, to watch or not to watch video. When we are talking about such events of two types, these types can be presented as zeros and ones. Zero means that during the session, user hasn't watched any film, and one means that during the session, user has watched at least one film. When we gather statistics over several sessions, we see samples of zeros and ones. Such events have Bernoulli distribution with the parameter p, where p is a probability of 1. Let's say that p is our metric, which is simply conversion from session to video watching. It's very easy to test hypotheses about p parameters of samples from different Bernoulli distributions. In the example, P1 is the conversion from session to video watching in Netflix with new recommendation system, and P2 is a conversion from session to video watching in Netflix with current recommendation system. If you assume that these changes in recommendation system affect conversion positively, you'll have null hypothesis is P1 equals to P2, and alternative hypothesis is P1 is larger than P2. If you have doubts about sign of the effect, it's better to use another version of test. Null hypothesis is the same, but alternative hypothesis is P1 doesn't equal to P2. Statistic that is calculated in such hypothesis testing is presented here. This statistic has a standard normal distribution. It means that p-value for one-tailed test can be calculated as presented here, and p-value for a two-tailed test can be calculated on the formula as presented here. P-value is the final indicator that influences business decision. In our case, the decision is to update recommendation system or not. Simply, p-value is a probability to obtain this difference just by chance. The less p-value, the more you can rely on the received difference. And now I open Google Doc. There is a table with two examples. Nevertheless, you see both p-values for a one-tailed test and for two-tailed test. You should use only one of them to decide whether the difference is statistically significant or not. And this choice should be made before the launch of experiment. Let's assume now, for a purpose of example, that we believe that new recommendation system is better. In the first row, The mean in test sample is only 2 percentage points higher than the mean in control sample, 52% versus 50%. And let's assume that it's 1,000 sessions in test sample and 1,100 sessions in control sample. This leads to absence of statistical significance of difference. And the probability to obtain given difference by chance is 18%, which is quite large. We fail to reject the hypothesis. And from the practical view, it means that it's not obvious if new recommendation system is better than the current one. In the second row, mean in test sample is 4 percentage points higher than the mean in control sample. This leads to a statistical significance of difference, and the probability to obtain this difference by chance is only 3%, which is quite small. In this case, we reject null hypothesis and conclude that the conversion in test group is higher than this one in control group. From a practical view, it means that the new recommendation system is better than the current one. Now you can copy this Google Doc and play with numbers in the table. You need to change only light blue cells, that is test sample mean test sample size, control sample mean control sample size. You'll see how changes in these cells affect the p-value and the decision. Ask me any questions about formulas listed in the video and their applications. I hope that this video was useful for you, and have a nice time exploiting this instrument, which doesn't require any coding and could be applied right from the box. See you!